Hey everybody, this is Emma Jacob and Courtney Brown, and this is our Homework 17 for Engineering 460 Digital Simulations at Liberty University. Alright, so Homework 17 is basically a hospital ward simulation problem. It is specifically our problem number 7.2 in our textbook, which is in Appendix 7. So before we go any further, just wanted to let you know that we did not end up getting this code to run correctly. But what we'll do is we'll take a quick overview of the code, kind of show exactly what it's doing, and then we'll go from there. So again, we did not get in results, so if you're looking for results for problem number 17, 7.2, we do not have them in this slide. So I broke up the code into 3 separate slides because the code is fairly large. What we did is we created a function called hospital ward, which takes inputs of SymTim and T0, alpha, lambda, mu, beta, seed1, and seed2. SymTim is the time of simulation, N is basically the number of beds in a unit. Again, we're doing a hospital ward. T0 is obviously going to be the beginning of the beds being unoccupied, so it starts with 0. Alpha, lambda is going to be arrival rates. Mu is going to be average, obviously beta, and seed1 and seed2 is just being able to generate random variables the way we'd like them to. So what we can see here is we can initialize some of our first things. So seed1 and seed2, we initialize a random number generator using the twister parameters. Beta 1 we define here, beta 2 we define here, and beta 3 using the answer of the resultant of the gamma of beta 1 plus 1. And then we ask the user a few questions. We want to input seed 1, so we ask for arrival seed value. Input seed 2, we ask for the service seed value. We want to look at the run length in days, so this is our simulation, SymTim. So we ask for that. We ask for the number of beds, which we set as n. We ask for the arrival rate, which is a Poisson arrival rate per day. We set that as lambda. We ask for the mean, or mu, which is the mean of the length of stay in days. That actually ends up becoming beta 2 over mu, but the way we end up doing that is just looking for that input, which is the number, and equating it to beta 2 over mu. And then we ask for the standard deviation of the length of stay in the days, and that ends up becoming actually what we're looking for is just that value is a square root of beta 3 minus beta 2 squared over mu. And the last thing we look for is the early departure parameters in days, which is the alpha, and then we can ask for it there. So this next little bit kind of looks at the number of occupied beds. We set at 0, which means that our first initial cumulative, so added number of occupied beds, is going to be 0, and we run through a little for loop that basically says if the occupied beds is less than infinity, which it is, then go ahead and go through an occupied bed, else add this cumulative of number of beds occupied, then it's to 0. So let's look at the next slide then. So the next part of the slide is going to be initializing other variables, sorting some additional departure dates, sample time of first arrivals, and advancing simulation to first event. So we set our Q, which our Q is going to be either 0 or 1. If it's 0, then basically a patient is awaiting admission. If it's 1, if it's 0, the patient is not awaiting admission. If it's 1, it is awaiting admission. NA here is going to be the cumulative number of arrivals, and out 1 is going to be the cumulative number of normal departures, and out 2 is going to be the cumulative number of early departures, and so on and so forth. So what we'll do is end up initializing some of our variables. Our clock we set at 0. We want a random number seed1, a random number seed r1. And then again we set our alpha here, which was a to our, and then we look at our clock and our clock previous. So basically what it's going to do is it's going to be able to now differentiate between our clock at the beginning and our clock at the end of an event. And basically what we say is while we're in the simulation time, while the clock is less than the simulation time, let's run through a few different options. So if the clock is equal to the alpha, then we set NA equal to NA plus 1. We set the random variable for seed1 for R1, and we run through and we now assign that Q is equal to 1. Q being equal to 1 means that we are awaiting, there's a patient awaiting arrival. Else, basically say that there's not. We can take out a patient from the number of occupancy, so we can reduce that number, and then add to the number of out when it comes to, again, the normal departures. Now, if Q is equal to 1, in other words, there's an occupancy and the number of occupied is less than n, the total number that we're running, then it runs through a different scenario here, where we end up running, again, initializing all the variables. We take this, the number of occupied beds, and we take that clock number from it, and so on and so forth. And then we have another scenario where we have, again, the bed is occupied, and the number of occupied is equal to n, and the clock is less than alpha. Basically, then we run through these ones. Last scenario is q equals to 1 again, number of occupied is equal to n, and t sub 1 minus clock is less than alpha, is greater than alpha, I'm sorry. Again, we run through iterations, we set our clock, and then what we'll end up doing is at the end of all those simulations, we basically set our time of our simulation equals the clock. Our delta, which is what we started off with and what we ended with, is here, and then we set the number of how many occupancies we had. So then what we'll end up doing is computing the average utilization, the referral rates, reduction in length of stay for referred patients, and list F for plotting bed occupancy distribution. And what that ends up doing is, here towards the end, you can see basically we're able to plot our utilization, our referral proportion, our early departures, and our average reduced stay for early departure and short. So that is the basic gist of our code. If you have any insight into how to make this complete and run, then let us know. Again, we had no results and our code would not run. Thanks for watching.